Sago palm, also known as Metrosalin sago, is found in Southeast Asian archipelago. The plant is known to produce the greatest amount of starch from its trunk compared to other starch-producing plants. New Guinea and Moluccas Islands have been considered a sago biodiversity center due to their vast natural stands and high genetic variation. Certain varieties in Papua Indonesia can yield as high as 1 metric tons of starch per trunk. The largest cultivated area are found in Sarawak, Malaysia, mostly located at riverbank areas at Batang Rimbas, Batang Seribas, Batang Krian, Batang Igan, Batang Muka, Batang Oya, and Batang Belingiat. It thrives well in swampy alluvial soil but can also survive in a hostile environment where other plants will not. It can also play a role as riverbank stabilizer through its sturdy roots, trapping silt load and industrial pollutants. One of the foremost important characteristics of this palm is that it is a perpetual crop and it doesn't require replanting compared to other commercial crops such as oil palm. Sago palm is one of the oldest plant species used as a source of carbohydrate before the emergence of rice and other cereals. It has been a staple food among the Proto-Malay in the Southeast Asian archipelago island for centuries. In Sarawak, sago is associated with the Melanau community. Among their popular food products are tabaloy, linut, and sago pearl. Sago is not really a new commercial commodity in the Southeast Asia region. It had been traded since 700 years ago. Food and Agriculture Organization of United Nations (FAO) had identified sago palm as a crop for the future to solve the hunger and malnutrition of the increasing world population. Although Indonesia and Papua New Guinea have the biggest hectareage and is the biggest producer of sago starch in the world, Sarawak is still the largest world exporter, with Muka Division as the main producing area. Sago is one of the major agricultural export earners for Sarawak. Although the export volume has not really increased over the last 10 years due to short supply of sago logs, the revenue, however, has increased substantially from 40.6 million ringgit in the year 2005 to 90 million ringgit in 2015. With the introduction of new value-added products, we believe that there will be a continuous increase in demand for sago starch in the future. Realizing sago as the export commodity that contributes significant revenue to the state, the Sarawak government made a bold move to start the development of a commercial sago plantation and Sago Smallholder Satellite Estate (SSSED) with the aim to increase the production of raw materials and to expand the sago planting areas. A success of the development of any industry requires strong R&D support to generate new technology. Thus, CRAUN Research Sendirian Berhad was established in July 1993. CRAUN pursues R&D strategies that ensure the sago industry is globally competitive and sustainable, increase producer income, and fully utilize the palm and achieve zero waste. In order to realize these strategies, various research programs have been formulated which cover all aspects right from the crop production, processing, product development to waste utilization. The upstream research relates to crop production and field management. The aim is to improve the performance of sago palm grown on peat and mineral soil by examining ways to reduce the maturity period, increasing the starch yield, and reducing the crop losses. Crop improvement aims to develop high-yield good quality starch and short maturity palm. Mass production of sago planting materials will carry out through using extracted suckers managed on raft and polybags, through tissue culture technique. At the same time, CRAUN is also undertaking molecular research to generate new high-yielding variety. Agronomic and cultural practices aim to produce sustainable and cost-effective field technology to ensure good crop growth and high productivity. As harvesting of sago palm will take at least 8 years prior to first planting, integration of sago with other crops were initiated to provide early income for sago farmers. Pineapple has been found to be a suitable crop for this purpose. Therefore, CRAUN has made an initiative to produce pineapple planting materials through vegetative and tissue culture. Field mechanization and post-harvest handling aims to reduce drudgery and labor requirement, efficient input distribution, and to sustain quality. Milling and refining technology aims to develop more efficient starch processing and production of high-quality starch. Product development and improvement aims to exploit the unique characteristic of sago starch for product diversification and development of new products, at the same time, improvement of conventional products. Economic and industrial development research aims to optimize farm management practices, determine the marketability of the developed product, provide relevant and timely information regarding market trends and the statistical data of sago industry. In order to ensure the technology generated benefits the sago industrial players, CRAUN is pursuing the following transfer of technology programs: technical training, technical advisory and consultancy services. In addition, CRAUN also publishes scientific information and journal and report. In order for CRAUN to achieve its research objective, there is a need for strong collaboration with other relevant R&D agencies and Institute of Higher Learnings at state and federal level. This is due to constraint in terms of specialized research facilities, information resources, experienced research expertise, and finance. Through its research program, CRAUN has made commendable achievement. Quality of planting materials had improved through research and sucker selection and good nursery practices. Sago clones of local origin have been successfully produced through tissue culture. Those field planted have shown normal growth and producing equivalent starch yield as per their sucker origin. Mass production of high-quality clonal planting material is being actively undertaken, and in 2013, a new tissue culture commercial laboratory has been established with a capacity to produce 400,000 sago plantlets per annum. Introduction of correct amount of fertilizer application, efficient weed control and other good cultural practices have resulted in vigorous growth of sago and shallow peat, and trials are being continued on mineral soil at the SSSED location. To maximize crop yield per unit area, a higher density planting of 100 to 145 palms per hectare was introduced. The design was also formulated taking into account the future harvesting paths and light penetration for optimum photosynthesis. Development of various new sago products and new application create a new niche market for sago starch. Breakthrough in waste utilization not only conserve the environment but also convert waste into wealth. However, there is still plenty of research to be carried out. New, emerging and futuristic technologies need to be generated to ensure that sago continuously remain a competitive and sustainable industry which contribute considerable revenue to the state.